Example 2. Find the dimensions of a rectangle of area 225 square centimeters that has the least perimeter. What is the perimeter? I began this minimization problem by drawing a rectangle, designating one set of sides as x and another set opposite as y. What we want to do is minimize the perimeter, so the objective function would be p, and the perimeter is the sum of the two opposite sides, so 2x, plus the other opposite sides, 2y. A constraint given in the statement of the problem is that the area, which we know as x times y, is 225. Now we're going to go ahead and solve for y, so we get 225 divided by x, and that's equal to y. We need our objective functions in terms of one variable, so we'll take the perimeter, which we know as 2x plus 2y, and to make it a function of x, p of x equals 2x plus 2, and where the y was, we'll replace it with its equivalent x form, which would be 225 divided by x. We'll do some algebra, and we'll get p of x equals 2x plus 2 times 225 is 450. And to make it easier to differentiate, we'll write the 1 over x as x to the minus 1. So what we need to do then is to use a derivative test to minimize the function p of x equals 2x plus 450x to the minus 1. In order to use a derivative test, we first begin by finding critical values, if any. Critical values are where the derivative equals 0 or the derivative is undefined. Now let's take the derivative. P prime of x is equal to, the derivative of 2 times x is just 2. The derivative of 450 times x to the minus 1. We bring the minus 1 down and multiply it to the 450, so that'll be minus 450. And then x to the minus 2, because we subtract. Now let's set that derivative equal to 0. 0 is equal to 2 minus, and I'm going to write this 450 over x squared. Let's begin to solve for x. I'll add 450 over x squared to both sides. So I get 450 over x squared equals 2. And continuing, let's cross multiply so that we get x squared is equal to 450 divided by 2, which is 225. And when you solve for x, you get negative 15 and positive 15. Now at this point, common sense kicks in and says negative 15 cannot be a measurement because we're looking at a physical quantity. Even so, we still have not demonstrated that the positive 15 gives us the minimum parameter. So we must continue with the second derivative test. That means we're going to take the derivative of the first derivative, and the second derivative would be, the derivative of 2 is 0. Now, we've got negative 450 times negative 2. That would be positive 900. X to the subtract 1 from negative 2 is negative 3. So we need to evaluate positive 15 in the 900 divided by where the x was. We'll put in 15 cubed. I'm not going to compute this. What I do know is that a positive number divided by a positive number is positive. And if the second derivative is positive, so if the second derivative is positive, then we know that it is concave up. And if it's concave up, the most extreme point is a minimum. We have demonstrated that at x equals 15, I believe the units of measurements were centimeters, we have a minimum. Now we were asked to find the minimum perimeter. So the perimeter is 2 times 15 plus, and 2 times, we've got to solve for y. Y is equal to 225 divided by x, which would be 225 divided by 15, which is 15. 2 times 15 is 30, plus 2 times 15 is 30, so 30 plus 30 gives us 60 centimeters. So the minimum perimeter for this rectangle is 60 centimeters.